Alright, so now what we're going to look at is phases of matter. So phases of matter, you more than likely know what a solid, liquid, and gas is. But we're going to look at it a little bit more clearly than just stating the obvious. Now, stating the obvious is important so we can kind of see why this is happening, like what's going to happen. And I have it spaced this way because we're going to look at a phase change diagram, okay? But we're not quite there yet. So let's look at what a solid and a liquid and a gas is just so we can kind of have an idea, okay? So my idea, for a solid, if I have a container, right? And I have a container, it's all solid, and these circles represent the substance of the solid. So we can just say, we can do anything, all right? Any substance that's on the periodic table. But if we just say, I don't know, something fun like oxygen, because it needs to be really cold to become a solid. But anyways, any substance, water is fine too, but basically they're very close together, okay? So the idea here is that the atoms are moving. The atoms are moving between. They're the compounds. So if we're talking about water, it's a compound. If you looked at the other videos I've done, that's a compound. If you're looking at just single elements on the periodic table, well, then those circles would represent the atoms, not just the compound. Anyways, they're close together. They're vibrating. They're moving a little bit. So I know that's kind of hard to imagine, but solids do move a little bit. And when you start adding energy, okay, so we're going to go across here, and as I go across, okay, we're going to go this way, I'm going to add energy, okay, in the form of heat. So when I add heat, we have to look at what's in between, what's keeping those little atoms or compounds together. And that's an attraction. And the attraction is either strong or it's weak. If it's weak, you don't have to add a lot of heat to break them apart. If it's very strong, then you would have to break them apart with more energy. Let's just use an example of what you're breathing in right now. Oxygen. Oxygen is a gas at room temperature. Therefore, it does not need a lot of energy to break it apart when it was a liquid. So it would have to be very cold for it to be a liquid to get it really close together because the attraction isn't there. We'll get into that a little bit later in another video, but the idea is there is some sort of attraction here on the solids. And we have to add energy to break them up, to make them move more, because if you want to add heat, you simply add the movement. So if I add heat, you can add heat by doing this. What am I doing? I'm moving my hands together, and that movement, kinetic energy, creates heat. So I just want to get those atoms moving around a little bit more. So as I add them, my container now has a liquid. And a liquid is where the substances are not as close together. They're separated. They're not bigger. I just kind of drew the circles a little bigger, but that's not the case. The idea, though, is that they're sticking together still, but they're not so close together. Okay? They're spreading apart a little bit. Chocolate melts. It's spreading out. The atoms of chocolate, so to speak, the compounds, they're not sticking together as well. They are still sticking, though. You can see it. They are sticky. So if I keep adding more heat, I can break that attraction and completely break it apart so that the compounds or the atoms themselves, they're going to be so far apart they're not sticking anymore. They're just bouncing off each other, and when they bounce off, they don't stick. If they're a liquid, they're going to bounce off, but they're going to stick to each other and stay within a range of each other. Solids, of course, are really close. They're very sticky. So no attraction here, because I have them moving so fast. So I can even put fast moving over here. So that's kind of what high heat is. They're fast moving, and over here it's slow. Okay? So the more heat, the faster they move. Okay? So knowing that idea now kind of gets us to the point of using a phase change diagram. So I'm going to make this a graph now. All right? So we're going to have this be an x-axis, which is heat, and And over here, we'll just say it's over time. All right? Or actually, we don't even really need to put anything over here. Okay? The main idea, I guess we could put time. That's fine. We'll put time. As I add heat and time increases, I will get to a gas. Okay? So let's just say I have ice and I'm melting it. So that's a phase change, right? So we're going to go into a phase change now. So this is a phase change. So we're talking about phase changes now, okay? Phase change diagram is exactly what this is called, diagram. All right, so when I have a solid, I'm going to start with a solid, okay, obviously. And as I increase heat and time increases, I am making it get to a certain point where the solid, I mean, let's think about it like this. Can ice be a solid at -10 degrees and -20 degrees? Yes. So I can have a range of temperature, okay, of heat that I can add, and it won't change. It will still be a solid, okay? So it depends on the matter itself, okay, how long it takes to, where I add heat, where it starts to not become a solid. But there is a time where this is all a solid. But then we get to a point, okay, where I'm actually starting to make it where it's it's breaking apart a little bit. So if I'm going this way, because you can actually take heat away, remember, but if I'm going this way, I'm going from a solid to a liquid, I'm going to melt. But if I take heat away, then I'm going to go to a solid, I'm freezing. So I'm basically going in both, I could go into either to the left and take away heat to freeze it, or I can go to the right and I can melt it. Anyways, at this certain point, I am no longer increasing my temperature, okay? I'm just adding heat, and there's a certain point where I'm not adding, the temperature isn't changing. In fact, I'm going to change this to temperature, which is a measurement of how much heat I'm adding, okay? So let's just say we're going to start at -20 degrees. See, right here, this is where we have a chunk of ice. We'll just use that as an example. I'm adding heat, okay? But as I'm adding heat, the temperature is changing, but once I get to 0 degrees Celsius, that's where I'm starting to melt. I'm reaching a point of melting. It takes a while before that temperature will change, because as I'm adding heat, I am breaking those attractions. So this is where I'm breaking attractions. Okay? So as I'm breaking attractions, I'm melting it if I'm adding heat, or I'm freezing if I'm taking away heat. Eventually, though, I'm going to reach a point where it's all a liquid. So this is where I have all a liquid along this point, kind of like a solid. Now, think about a liquid water. Liquid water starts at 0 and goes all the way to 100 degrees. So in between 0 and 100 degrees Celsius, 0 and 100 degrees Celsius, you can have different temperatures of water. You drink a glass of water, you're like, oh, that's warm, or that's cold. It's still water, though, in this chunk of time, this area right here. So I have a liquid along this slope here, okay? I'm not breaking any attractions. It's liquid, all right? But I get to a point, and every substance has a point. For water, it's 100 degrees, where it starts to become, where I'm breaking attractions, and I'm going to not melt it, but I'm going liquid to a gas. So I am going, if I'm adding heat, I am going to boil it. So I'm boiling, okay? Evaporating, right? Boil, you could say evaporate. All right, and if I'm going this way, say I have a gas, and you know this before. If you have a gas and you're going to a liquid, that's like you have a taking a hot shower in winter and the mirror is cold, you got that liquid, that gas, water is going to condense on that mirror. You've seen it a lot, many times. Anyways, that's condensing. So condensing is taking away heat, and if I'm adding heat, I'm going to evaporate it or boil it. Okay? There's a certain point, though, where I am going to have it all become a gas. And a gas can be, as you know, it can be really hot and still be a gas, and it can be kind of cold and still be a gas relative. But this is where you can increase heat and still be a gas. This is where steam becomes really dangerous, because steam can be it can be more than 100 degrees and still become a gas, right? So you could have a really, really hot steam, and that's where it can be hard, it can be very dangerous because it can get really, really hot and still become that. So basically, I'm going to take away my solid here, okay? And I'm going to complete my phase change diagram, the gas, okay? So now that we have it all together, we know that the slopes, I can have a solid at different temperatures, right? So I'm going to start with a chunk of ice at 0 degrees, and I'm going to heat it up. It's still a solid along this slope. But eventually I get to a point, just like ice, there's a breaking point where it becomes a liquid. Chocolate would be a less temperature. It would be it would be a little bit warmer, because chocolate would melt at a little warmer, right? So chocolate, just imagine that this would be a different temperature, right? But every substance has a point called a melting point, right? So this is our melting point. Melting / freezing, whoops. Melting / freezing point, where you are going to break attractions. And you're going to melt it till you get to a certain point where all the heat now has made it so that the heat has made it all where you're having a gas or a liquid here. So all of this is now a liquid along this slope. Okay? So I am getting to a point where I'm going to melt it, and I'm going to get all the way over to a certain point where the liquid now it's all a liquid. Now you can have water at a much big range. You can have warm water, you can have cold water. So this is a big range, right? From 0 degrees, right? 0 degrees, all the way to 100 degrees. So once we get to 100 degrees now, though, we reach its boiling point. And we could also say it's its condensing point. Alright, so that's where you're going to be breaking attractions again. You're breaking attractions. The attractions of the water molecules are starting to separate. You're going to break them apart, where eventually you're going to become a gas now. So all these guys are gas along here. And the temperature of gas can range, and that's why it keeps going up. All right? So this point, so you got to remember that, I guess the horizontal lines are your points, melting point, boiling point. And your slopes are your phases. Your slopes are your phases. Solid, liquid, gas. Gas, liquid, solid are your slopes, and then your points are where things are going to melt or freeze and boil or condense. All right, so every matter, everything you ever think of has one of these, okay? And the temperature change, or the temperature needed for these to happen, will vary based on that matter, okay? So looking at this a little differently now, hopefully you understand a phase change diagram related to heat and temperature. And you'll be able to have to identify this and see what parts of these mean what. So make sure you're able to make one on your own. You might want to rewind this and try making one on your own and then compare it to what you have here. Okay? Good luck.